welcome to this video, in which I'll be covering laws of indices. Okay, or the index laws, as they are commonly referred to. Okay, so this video is tailored towards A-level math students. But if you are a GCSE student, you can still watch this video, as I do know index laws comes up quite often as well at the end of a paper, so they're normally worth a few marks that can push you up to the next grade or drop you down to the other. So if you would like to extend your knowledge, and that's perfectly fine, you can watch this video. And it's also tailored towards the Edexcel A-level specification, hence I have part of it on the screen. But if you are studying A-level math and you are with another exam board, then do not worry, because this laws of indices does come up quite a bit in all the Core 1 modules, I think, across the examining bodies. And it's still good to watch videos from other exam boards to deepen your knowledge, because you might find a video from someone else on laws of indices just for the AQA exam board, but if you look at my video you might find another method to do to solve a problem, for example, and you might prefer that method. Okay, anyway, in this video, like I said previously, we'll be covering laws of indices for all rational exponents. That's what Edexcel require you to know. And I'll also be you also have to know this law as well. So not just the basic laws, you need to know some more complex laws, although they're not difficult at all. Okay, so here are all the laws you need to know. Some of them you may have seen at GCSE, although you should have seen all of them, but you may not remember some of them because your teacher probably didn't stress on some of them because they rarely come up. Okay, and what we are told at the top of the picture is that this part here is called the base, and what it is raised to is called a power, exponent, or index. Preferably, I like to call it a power, but you can call it whatever you want. Okay, so we will be using all of these laws in this video today. Now on the next slide, there are 7 questions which I would like you to have a go at. I know I haven't gone through or taught you any of this, because you should really know this from GCSE. So all I'm going to be doing is giving you questions so that you can practice and practice and practice with them. Remember not to use a calculator, because Core 1 is a non-calculator paper. Okay, so here we go. What I would like you to do is simplify all these expressions and come back and watch the video when you are ready. Okay, so have a go, pause the video, have a go, and come back when you're ready. Okay, so welcome back if you had a go. Now let's go through the questions to see if you got the right answer, or if not, where you went wrong. Okay, so part A. This is very simple. At GCSE, this is something that would come up, but at A level, I would doubt that this would come up. Okay, you're likely to get something more complex. But I've given you this question just to give you a bit of a start and get you in the role of things to get you going. Now, what you should identify is this relates to the law a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n, where the bases a are the same. Okay, so therefore we can say that x to the power of 6 multiplied by x to the power of 4 is equal to x to the power of 6z4, which is 10. Okay? So well done if you got that right. Part B. We are asked to simplify x to the power of a half. Now, this is a very simple expression. You should be able to use instantly, but this does, you should know that this is equal to the square root of x. And how did I get that? Well, the law, x to the power of m divided by n is equal to the nth root of x to the power of m. Now, in this case, m is 1 and n is 2, so let's substitute that in. Well, what we would get is we'll get 2, the second root of x to the power of 1. Now, this is equal to the square root of x to the power of 1. And x to the power of 1 is simply x. So therefore, that is how I got to that. Okay? Now, let's try part C. So once again, we visit the multiplication law of indices, and therefore, what you should know is that a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. Okay? Therefore, what we have is we can say that a to the power of 0 multiplied by a to the power 1 is equal to a to the power of 0 plus 1, which is equal to a to the power of 1. And anything to the power of 1 is equal to itself. So this is just simply a. Now you could have done this another way. You could have said that a to the power of 0 is 1. So you could have done 1 multiplied by a to the power of 1. And anything multiplied by 1 is itself. So we have a to the power of 1. And a to the power of 1 is a. So you get the same answer. It doesn't matter which method you use. Now let's try part D. So we are asked to simplify 6b squared all squared. Now, which law will we be using here? Well, it's the law that says ab all to the power of m is equal to a to the power of m multiplied by b to the power of m. So therefore we have that 6b squared all squared is equal to 6 squared multiplied by b squared, and I'm going to put this in brackets, squared. Now this is equal to 36 multiplied by b to the power of 4. And therefore we have, this is equal to 36b to the power of 4. Okay? Let's try part E. And well done if you got that right. Okay, so this is a law that hasn't come up yet in the questions that I've given you, and you should be able to recognize this instantly from GCSE. And this law is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Okay? So therefore, a to the power of 6 divided by a to the power of 8 is equal to a to the power of 6 minus 8, which is equal to a to the power of minus 2. Now you could leave your answer like this, or like that, shall I say, but I would simplify it. And if we have any number raised to a negative power, then what we can do is we can take its reciprocal to make the power positive. And taking a reciprocal simply means to flip a fraction upside down. And what I mean by this is a to the power of minus 2 as a fraction is a to the power of minus 2 divided by 1. So therefore, if we flip that over, we have 1 over a to the power of minus 2. But because we found its reciprocal, we can get rid of that negative power. So we have 1 over a to the power of 2, or a squared. Okay, let's look at f. Okay, so f is a little bit more complicated, requires a little bit more knowledge of fractions and so on. but it's something that's more likely to come up in an exam, although something of this style hasn't come up yet, or else I don't think it has. Okay, because I think this is a bit too complicated, or else all the indices questions would be worth a little bit more. But this is not as complicated as it looks, because all we have to do is apply 3 laws. First of all, I'm going to deal with the numerator, and we can recognize that this is the multiplication law, which I've stated in previous questions. And if I just write it down here, it is a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. So therefore, our numerator can be written as x to the power of 5/6 add a half. Now what is 5/6 add a half? Well, that is simply 8/6, which is 4/3. Okay, but if I do that the long way down below and I show you how I got to that, then what we have is we have x to the power of 5/6 add a half. If I make the numerators the same by multiplying the second fraction by 3, I get 3/6, which is equal to 8/6. And if I simplify that, divide top and bottom by 2, I get 4/3, and therefore I have x to the power of 4/3. But at this stage, you should be able to do that in your head, or else as practice, you should be able to do that in your head. Now, if we look at the bottom, how can we simplify that so that we can get it into a standard index form, just so we can simplify this? Okay, well, you should know that x to the power of a half is equal to the square root of x, and therefore the square root of x is equal to x to the power of a half. So here we have our denominator, becoming x to the power of a half. So therefore, if we use the division law, which is a to the power of m divided by a to the power of n, we get that this is equal to a to the power of m minus n. And therefore, what you should find is that you get x to the power of 4/3 take away a half. Okay, now if you simplify this by putting all this over a common denominator of 6, what you end up with is x to the power of 5/6. Okay, now I took the long way because I thought it would be much more easier for the purpose of this video. But if you did want to take the shorter way, which I will show you down here, what you could have done was you could have left the numerator how it was. If you had recognized that the bottom was also x to the power of a half, and you could have cancelled them out, and therefore you would have been left with x to the power of 5/6. Okay, either way you still would have got the same answer. Okay, if you didn't understand the quicker way, then just stick to the long way. It's fine, you'll still get the same amount of marks. Now, part G. Let's have a look at part G. Okay, so for this, what we need to do is we need to change the first term into standard index form, so we can simplify this using the multiplication law. So if we simplify our terms, what we get, if I change the colour, is x to the power of 2/3 multiplied by x to the power of 3. No, actually, it should be 1/3. For some reason, I thought there was a 2 here, but it should be 1/3. Okay, sorry about that. And if we add our powers, what we should find is that we get x being equal to 10 thirds. Okay, so well done if you got them all right. That shows that you're really confident with index laws. But if you didn't get them all right, then you might want to practice. And here's your opportunity, because in the next slide there is a real exam question which I would like you to have a go at. So here it is. It's the first question of the exam, and it's worth 3 marks in total. So have a go at part A and part B. Try not to look at the index laws because you won't have them in the formula book. So have a go at them and come back when you're ready. Okay, so welcome back if you had a go, and let's see if you got the correct answer. Now, what you should know is that anything to the power of a third is equal to its cube root. So 125 to the power of a third is equal to the cube root of 125. And the cube root of 125 is 25. Remember, you do not have a calculator, and you should read. Oh, sorry, is 5. Remember, you do not have a calculator, and you should be able to do this without a calculator. I just keep making mistakes. I don't know why. Okay, maybe it's because this was 25 and I just saw it, but I don't know why I wrote 25. Apologies for that. Now part B tells us asks us to find the value of 125 to the power of minus 2/3. So the first thing we have to do is get rid of this minus, and we can do that by finding the reciprocal, which is equal to 1 over 125 to the power of 2/3. And what is this equal to? Well, this is equal to 1 over the cube root of 125 then squared. Okay, now this is and the cube root of 125 is 5. I've got that right this time. And then if we square 5, we get 25. So we get 1 over 25 as our answer. Okay, so well done if you had a go and got the answers right. If not, you can always look at some past paper questions and try and have a go at them. And if you type into Google index law worksheets, I'm sure you'll find plenty for you to have a go at. Okay, so I hope you enjoyed this video and found it useful, despite the 2 mistakes I made in this video. And share this channel with all your friends. And if you did find this video useful, give me a like. It really helps me out. Okay, thank you for watching.